Hi, I'm Dan Bettinger with the IBM Cloud team. Today I'm here to answer the question, what are microservices? For those who don't know, a microservice is an application architecture that takes every application function and puts it in its own service that runs in a container. And these containers then communicate over APIs. To better understand what a microservice is, we should probably look and understand what a monolith is. A monolithic architecture is a server-side system based on a single application. In a Java world, for example, the application would be put into a jar or WAR file and deployed as a whole into a production environment. The thing about a monolith is they're easy to develop, deploy, and manage. But things happen over time. Let's use an example. In this case, pretend we are a ticketing service, one that sells tickets to sporting events and concerts, etc. In a monolithic world, the architecture might look like this, where we have a user interface, we have some semblance of an inventory component, a recommendation engine that provides outputs based on user inputs, maybe a cart service, we'd have a payment service, and then some type of reporting function to generate reports. So that's great. The thing you can realize right off the bat is that these are highly dependent systems or highly dependent software, meaning that there are shared libraries within this architecture. If you make a change, you have to understand what other components rely on those libraries. So they're easy to break over time. Another challenge we have around monoliths are that they are language and framework dependent. So in this case, if this is a Java application, any additional component that has to be written needs to be written in Java. So you're somewhat limited by decisions made in the past. Another thing that happens, and another challenge with monoliths, is growth. Over time, user input comes back into the product team, and they need to add additional functionality. So initially it's small, but over time you might need to add capability A, or capability B, for example, or capability C. Now, as a whole, the application is getting much larger. It's harder for a team to actually understand what's happening to it, and hard for a team to know every little intricacy about the thing as it grows. As it also becomes bigger, it takes heroic efforts to deploy the monolith, meaning that on a Friday night, you would have to shut down the original application and then actually deploy the new production application, and the ops team would spend all weekend trying to stabilize it and get it to run, so on Monday it can be up and functional again. That can be very painful for teams, and it can be really hard. Another challenge we have around monoliths is the way they scale. If it's really busy and there's lots of people trying to buy tickets in this example, maybe the payment part of the application is under duress and it needs some additional capabilities. What would happen is you would have to redeploy the whole application to help satisfy that demand and that need. So in this instance, we would maybe need to go ahead and redeploy another version of this system. What that looks like is right now is we have one system running. When this is under contention, we need to redeploy another version of that application. There's number two. The challenge is it might take a lot of time to go add that new application, the new instance of the application. And by the time it's up and running, that peak may have already subsided. And effectively, you've done nothing to help your users. So that's a challenge around the monolith as well. Let's look at the same example of the ticketing company in the microservices-based environment. So again, a microservice environment, we'd have the same functionality. You'd have your user interface. It would be in its own container as a service. You'd have your inventory service as well. Your recommendation engine would be in its own service. Your cart is in its service. We had the payment service, and we had reporting. So it's the same as the monolith. The difference is these all talk over APIs. And right off the bat, you can see something that's kind of interesting. Because they're independent, the team responsible for the reporting engine, for example, can choose a language and framework that they want to use themselves. They are not beholden to choices made by the team that run the cart or the UI or the payment system. So that's really good. It gives those teams flexibility. So that's the language part. Another benefit is the ability to iterate. Because these are independent components and they just talk over APIs, the team responsible for the reporting engine, for example, can commit code that goes through the DevOps pipeline, and once that gets tested and it's proven to work, it can automatically be deployed to the environment. So thereby, these teams can iterate as fast as they need to, bringing value to the customers. So that's fantastic. Additionally, these changes are minimal at best. If there is an instance where a service does fail, the rest of the application is still functional. So that's less risk. We also can scale these independently, meaning that in the case where there's a user or a number of users that drive load and that payment service needs some additional help, what needs to happen is the system can actually add capability automatically just for that particular service until that load subsides. So eventually what happens is when the load goes back to its regular cadence, for example, those systems and those additional services can scale back to normal. So again, just to reiterate, the microservices architecture is where every application function is its own service deployed inside of a container environment. They communicate via APIs. They're language and framework independent. We iterate at will through a DevOps pipeline. This reduces some of the risk that we see, and then we can scale these components independently. So thank you for your time today. If you'd like to learn more and see more lightboarding videos, check us out on the IBM Cloud blog.